In this problem, we're asked to determine the cosine values for some angles. Looking at each of these angles, they don't appear to be the angles that we have looked at on the unit circle. The reason why they don't seem to be the angles we looked at in the unit circle is that 23 pi over 4, if you look at this, 23 divided by 4 is going to be about 5.75. That does not fall between 0 and 2 pi. So these angles, all three of them, are outside of the usual domain that we've looked at, that 0 to 2 pi range for the angles. However, these angles are all coterminal with angles that we are more familiar with. In order to use that idea of them being coterminal with certain angles, we want to think about something called our reference angles. Pretty much what that means is that, well, I don't know exactly what these angles look like, large ones, but I know they relate back to a smaller angle that I do know more about. Maybe pi over 4, pi over 3, pi over 6, and that's going to help me find out the cosine values for each of these angles. Our first goal is to determine where each of these angles is. Our first angle, 23 pi over 4, we can look at it as being, well, 23 pi over 4 is like 20 pi over 4 plus 3 pi over 4. And here I've made a strategic decision to break 23 into 20 and 3 because 20 is the largest part of 23 that is divisible by 4. So I get 5 pi plus 3 pi over 4 more. 5 pi is a half rotation and another half rotation. That's 2 pi, 3 pi, 4 pi, 5 pi, and then there's this little bit more that goes like this, 3 pi over 4 to here. So that is where 23 pi over 4 is located as we spun around until we've reached our terminal ray. Now, we want to use our reference angle, which is, well, what's the shortest distance to the x-axis? And if this was 3 pi over 4 for the red part, it means there's pi over 4 left over here. So I want to think about what is the cosine of pi over 4. Well, cosine of pi over 4 I know is a square root of 2 over 2. But pi over 4 is not in the same place as the angle we're looking at. It's here in the first quadrant. Does that matter? Of course. But in this instance, the cosine of pi over 4 and the cosine of the angle we're looking at should have this same value because they're both on the right side of the unit circle. So cosine of 23 pi over 4 will be square root of 2 over 2. And we can do the same idea for all of our other angles. When I look at 13 pi over 3, I want to break 13 into 12 pi over 3 plus 1 pi over 3, because I know that 12 is divisible by 3. I get 4 pi plus pi over 3. 4 pi represents one rotation, that's 2 pi, 3 pi, 4 pi, plus a little bit more to get me to pi over 3. So my reference angle in this case is pi over 3, the shortest distance to the x-axis. So what I want to do is consider cosine of pi over 3. And I know that that value should be a half. This angle happens to fall in the exact same place as where the reference angle does. They would be coterminal. So in this case, we don't need to worry about changing signs. Our final angle, 37 pi over 6. 37 pi over 6 can be broken down into 36 pi over 6, choosing 36 because it's divisible by 6, and then one more pi over 6. So we have 6 pi plus pi over 6. That means we have 1, 2, 3 full revolutions, and then one more little piece. So I want to look at cosine of pi over 6, which is the square root of 3 over 2. And I don't need to change it from positive to negative because my angle happens to be in the same place as the reference angle we're using, pi over 6.